Okay, so back to business of completing this lab calculations. You should have your white kinetics of a reaction sheets out where you've been recording data and doing calculations, and then your colored sheet that has all the directions. We are on page 7 of the white sheet, and we're going to calculate the initial concentrations for the different experiments that we did. Okay, so here you have, so for the reactant, so this is what we're going to do to get concentration. Milliliters of A times concentration of A. A is a generic letter. Doesn't really correspond to A. It really corresponds to whatever concentration we're solving for. And we're going to solve for 3 different concentrations so that we have a reaction with 3 reactants. And we're going to figure out what their order is eventually. So we're going to calculate the initial concentration of each reaction and record it back in data table 2, which is back on page 2. So first we have to do the calculations, then we're going to go back and record that data there. So we're going to take the milliliters of the chemical that we're solving for times its concentration divided by total volume of the solution. So let's look at the first one here. We're going to do it for I, so iodine ion, for experiment 1. So this is iodine experiment 1. And so we see here that we have 3 milliliters. This is where the iodine is housed, the potassium ion and iodine ion. And we did 3 milliliters at this concentration. And if you recall from the previous set of videos, we had a total of 18 milliliters. So you're going to multiply and then divide, and we will end up having we'll end up having molar, big M, because milliliters will cancel, or moles over liters. So we're going to do that for experiment 1. And then we're going to need to do it for experiment 2 because the volume is different. So here it is for experiment 2. In this case, we had 6 milliliters of Ki at 0.01 molar. And remember, since this is 1-to-1, we can say the volume would be the same. And so we're going to do 6 divided by 18, and we get this value. And then we have 9 here. So we're going to do it a third time. For this one here, and I'm going to move this up and move it back down. So we have 9 milliliters at 0.01 molar. That's where I get this 9 milliliters, 0.01 molar. We get this value. Okay, remember we want to do 2 to 3 places that are non-zeros. So this could even be further out. If you make this go out one more decimal, one more non-zero, or one more digit, I guess I should say, your data will look a lot better and things will come out a little bit better in the long run. Basically, if we keep cutting off numbers, we keep getting further and further from a complete answer. And then this part here says experiments 4 through 7. So if you look at experiments 4 through 7, they're the same volume as experiment 1, so we're not going to repeat the same process. We're just going to refer to the fact that for iodine experiments 4 through 7, see this calculation that would be the same that we did in experiment 1. You will do the same thing then, going through a similar calculation for HI. So let's look and see where that is. That is housed right here. H is right here. H plus iron is right here. 3 milliliters at 0.1, so the 3 milliliters comes here, 0.1 molar, divide by that total volume again. You're going to do the same thing. If you look here, you will have these experiments 1 through 5 will be the same as experiment 1, and then you'll have to do a new second and third calculation for experiments 6 and 7. So you will have 4, like on this side, for H plus ion, you will have 4 similar. And then you will do the bromate ion, that would be down here, and you're going to see that. So you're going to do the same thing for the bromate ion. Remember we said that's here, and if you look here, you will do one calculation for 1, and then you'll say for experiment 2, 3, 6, and 7 to refer to experiment 1, and you'll have to do a second and a third calculation for experiments 4 and 5. So when you're done, you're going to have a total of 12 things, 9 of these and 3 of these per of the 3 types of for the 3 types of ions that we're solving for. All of these numbers then will be placed in the data table on page 2. So let's go back. This is the data table where you will place, all 21 of those concentrations. So all 7 of the iodine, the bromate, and the hydrogen. Be very careful you're putting the correct answers in the correct columns, matching up iodine with its 7 from your page 7, bromate with its 7, and hydrogen ion with its 7. The rates here also can be put in. These come from the work that you did on page 6. So bring those over also, and then we'll have this to fill in later. Okay, for page 8, we need to figure out what that rate law expression is at the bottom. First of all, we know that it's going to be something like this. So rate equals K, iodine to the M order, bromate to the N order, and H plus to the P order. Remember that we have to calculate what these 3 exponents are based on the data that we collect. So this is what you should write down when you get to the bottom of page 8 where it says, what is the rate law expression? This is what the data should look like on page 2 for iodine, bromate, and hydrogen. So check to make sure that you have like answers. This is rounded to 2 sig figs, so you may have to look at your numbers and at least visually round them to see that your numbers compare. If there's something that doesn't match up, please reach out as soon as possible to me. Via email would be great. Okay, so now what we're going to do is we got to figure out the order of M, N, and P. And if you remember when we did this in the first set of homework problems and on the first mastery quiz, we have to first set up when is this constant, when is this one constant, and when is this concentration constant. So let's start, and you can see here that we have 1.7 times 10 to the third, which happens in experiment 1, 4, 5, 6, and 7. So we wrote down 1, 4, 5, 6, 7 here. And then for this one, let's see, we have it constant at experiments 1, 2, 3, 6, and 7. And for here, you need to check that and pause the video so you understand how to do this. This will definitely be a question on your test. It was already been a question on your mastery quiz doing this skill. So we have these values here that are constant here. So go ahead and jot those down underneath and then pause and wait. Where do I mean by underneath? You could do that back on page 2. Underneath that data table there, so that you kind of have the knowledge that you need to draw from to complete the rest of this piece. Okay, so if you've paused the video, hopefully you pause the video on your back. If not, pause it and then come back. And hopefully you have been able to see that this experiment here is held constant with respect to experiments 2, 3, 4, and 5. That's when the number is exactly the same. Okay, so now we need to figure out when are the experiments able to be used, the formula that we know where it is rate 2 over rate 1 equals concentration over 2 over concentration 1 to the M power. Again, we're going to establish the orders like we did in the first mastery quiz and in our first homework set by setting rate 2 over rate 1 equals concentration 2 over concentration 1 all raised to the M power. Remember, that's where we had to ln both sides to get the exponent to drop down so we could solve. So to do that, we first will start with I. So on the top of page 8, we're going to look at iodine concentration. And remember, we don't focus on iodine. We focus on when is Br and H constant. So if you look here, I'm basically seeing for I, when are bromate and hydrogen constant? Well, they're constant with respect to experiments 1, 2, and 3, because I see 1, 2, 3 here, and I see 1, 2, 3 here. I don't see 6 or 7 over here, and I don't see 4 or 5 over here, so I couldn't put those. So my list for I would be when these two are held constant. So you are going to say for iodine that the experiment sets you can use when you do that equation of rate 2 over rate 1 equals concentration 2 over concentration 1 to the M power will be experiments 1, 2, and 3. And then it says explain how you arrived at this decision. Experiments where we picked these 3 because it's the experiments where bromate ion and hydrogen ion were constant. You need to do the same process for the rest of page 8 for bromate ion and hydrogen ion. And then we will continue with this on the next video. You should complete, though, all of page 8 now on your own, using this as an example of what to do for bromate ion and hydrogen ion.